Hello, my name is Alexei Konov. You might also know me as Mikhail. I am one of the authors of Rustnizer project, the next generation IDE for the Rust programming language. I have this crazy idea where I want to record a series of video lectures about Rust Analyzer for about, I don't know how many videos, but roughly half an hour video for each specific area in Rust Analyzer. The goal for the series is to let people watch only a specific small video to understand a particular area of the code base. For example, if you want to contribute new exciting completion version, you can just watch a video on completion and that hopefully will give you enough context to get started. Now, I haven't actually recorded such videos before, so in this 0th installment we won't actually be discussing any specific area of Rust Analyzer. Rather, I want to do some hack and record kind of things, just to see how the recording setup works on my machine. I will still upload and publish this video, and it might be useful for someone, but don't expect this to be terribly useful. So, what are we going to do today, besides me messing up with OBS Studio and figuring out recording? I want to fix, or try to fix, or at least investigate one particular issue in Rustnizer repository. So let's go to the issues and look at the broken window label. We use this label to label issues which need kind of an ASAP fix. It's not that something is completely broken, but that's the things which, if you fix them today, you won't waste time tomorrow. And there is this particular issue that computing visibility of an item is linear, and basically, like, the broader context here is that sometimes when you do IDE stuff, well, you have like a lot of structs, a lot of fields, a lot of functions, and you want to do something for them. For example, in completions, you want to list all available functions and such. And the problem here is that if for one function you do a linear scan of something, that's okay. But if you do this for every function, then you kind of have an O n squared or asymptotic quadratic runtime performance, and that's pretty bad. So this issue is about this visibility of functions, which starts to be linear and which feels like it might be a performance issue. So let's investigate it. I will go to Rustnizer project. I will switch to the main branch. I will update it to the latest state, and I will also quickly rebuild Rustnizer from source, just to make sure that we are using the latest version we have. While just building, let's actually look if we have a reproduction here of an actual performance problem. Yeah, no, so it's just kind of a theoretical observation that this might be quadratic, but we don't know if this actually is really the case. Okay, as you see, no, actually the CPU usage is still high, so we're still compiling. Okay, now we are using only one core, so we are probably linking, and finally we finished. Yeah, this cargo install thing installs both the server as well as the Scout extension. So now let's open Rustnizer itself and take a look what's running the function. It's visibility of in item scope. Visibility of in item scope. Yeah, here it is. Okay, so let's clarify that it is indeed quadratic. What's happening here at all? Okay. So we have this item scope start. Item scope is basically a set of names you see in a module or in a block. It's a block with inner items. As you might know, Rust has several namespaces, so you can have things like struct s and function s, which returns the struct. Yeah. I don't know about you, but I don't really like how the font is rendered here. I wonder if that's some issue with line height, so let me try to fix this. Font size, line height, oh yeah, yes. Line height is actually smaller than the font size. That's okay. Yes, okay, that's much better now. Anyway, yeah. So this actually is valid Rust. I guess we can just run the compiler to see that it doesn't error. And that means that you kind of like the same name can be visible in different namespaces. Specifically, Rust has like 3 main namespaces. It's like types, values, and macros. And this is how this item scope type is organized. There is a map for each namespace, and map maps a name to a specific item, which is visible in the scope, and also to the visibility under which this item is visible. Yes, so when we go to the visibility of function, we see that it actually does reverse lookup. So it takes an item, a definition, and it wants to compute visibility. But because visibilities and definitions are values in a hash map, what this function essentially has to do is it has to iterate all these maps linearly and find the items. Okay, so as we see, like this name of returns the name, and then we, using this name, we look up the thing. And the name of is like the main culprit here. This is like the function which does the linear lookup, because this entry function just chains all 3 of the hash maps. Okay, so let's see what are the colors of visibility of. Okay, the color of visibility of is this visibility of in the HAR module, and that's actually an important detail. So this visibility of we are looking at is inside here dev crate, and here dev crate is part of the internal compiler infrastructure. So this is not like public API. This is not API visible by an ID. In Rust Analyzer, we don't have truly public APIs, but we try to maintain API separation between what is the internals of the compiler and what is the IDE. So here dev is the compiler, and this visibility of is called from the here crate, and here crate is actually the facade of the compiler crates. This is the API which compiler exposes to the IDE. So yeah, any color to this function is potentially a problem. I guess we have some colors here, but none of them seems to be too problematic. That's interesting. When I last looked at this issue, I thought that it was also triggered by auto-importing infrastructure. Let me verify this second time. Okay, yeah, that's indeed just a single usage of this visibility of. And yeah, it seems like it just is called from a bunch of places, none of which is particularly important. Okay, so yeah, so let's look at every one of them. Visibility. Okay, so here are we looking at the visibility of the module, and while the visibility of we're thinking about should return us a visibility of a name in a particular scope, this visibility function intends to return a default item visibility to, well, maybe not default, like inherently. To give you an example, let's say we have a public FNF, and like this function is like public, but we can also have a mod m, which uses pub crate use super.f, and like in this scope, the visibility of f would be pub crate, although the visibility of the function itself is public. Okay, so it seems like that we actually compute this correctly for every item except the module. Okay, so let's look at why we can't just compute visibility in the same way for a module. I'm like forgetting the shortcuts here. Yes. So this is a name, and I want to go to the type of this name. There is a handy go to type definition shortcut in VS Code. I don't know like the default shortcut, but for me it's like this one. Okay. So again, this is type from here, and let's look at the implementations here. Interesting. So this this is exactly the thing which has like visibility of an item inside the module, which we want to get rid of, like to do duplicate and remove this. This is auto_ip. But what we really want to do here is we want to have visibility function, which takes a module, a database, basically like everything in Rust Manager takes some kind of a database argument, because that's where all the things are stored, and it returns visibility, and we need to figure this out. Okay, let's go back to this call, and here we want to say it's visibility db. Oh, okay, so at least now this code hopefully compiles, and while it is compiling, there is a variable here. Let's actually see if this change breaks some tests. CarrierQt is an alias. We have a bunch of aliases defined here. I think. Wait, why this doesn't say anything about the alias? I'm confused. Why does Qt come from that? Is it? Oh, sorry, that's my home config. CarrierQt is here. Yeah, so here it is. Okay, yeah, and as we see, a bunch of tests fail, so at least we know that some code paths are hitting this functionality. Okay, so let's try to figure out how to implement this visibility on a module without without going via this visibility off, which is potentially quadratic. It makes sense to copy part of this implementation. Actually, I don't really like this like really nested expression Let's extract this into a variable. Yeah, much better. Well, not much better, but a bit better, but every bit helps. Okay, so we have a def mark here. And this actually returns module data. Probably it makes sense to extract this as well. Yeah. I like how NDE correctly guesses the right name for the local variable here. And I believe what you want to do is to say something like module data visibility. Why doesn't it have a visibility? Visibility. Okay. So again, we go to type definition of this thing, and we see that yeah, we kind of like have parent-children scope, but we don't have visibility. I wonder if some of these things can't have visibility. Yeah, it seems like we just need to add a visibility field here. Now this hopefully should compile. Well, no, it's unlikely to compile because default is not satisfied. I wonder why we need default for module data, especially given that default for module origin. Okay, that's funny. I wonder if it might actually break things like. Let's actually, because we have an issue where something complains about file with 0 missing, and I wonder if that might actually be the root cause here. Okay, so let's copy GitHub in here and see this issue. That one also was broken window, I recall. Okay, so let's pivot this a bit. I definitely don't like that we have default for module data and we have like default for module origin. It feels like this might cause problems down the line, so it's better to remove these defaults and fill them explicitly. So what we do here is we will create a new branch, fix this of commit our current work in progress, switch back to the main branch, and let's check that we can compile stuff. That's really strange. Why cargo check doesn't work immediately after switching to the main branch, which is checked by Boris, so it should be correct. I wonder if that's like some incremental compilation back, which I'm not sure what's the current status of in C. So let's just remove the target directory and see if it helps. Yeah, apparently target directory was an issue here, so let's just run a test here as well, just to prime target directory again. Okay. So what we want here, I think, is remove this default field and see what breaks. You might have noticed that when I want to run cargo command on the whole repository, I tend to use terminal, but when I want to check a specific crate, I use built-in RustNicer functionality. I really would like to have an ability to run cargo command with completion and all that stuff from inside VS Code, but it doesn't currently expose API for that. Okay, and we have two usages here. Let's look at them. Yeah, and this usages are created who actually feels this module. Yeah, not super clear what's going on here. Okay, let's go back and see the other usage maybe. Okay, that was the first one. That's the second one. Push child module. Okay, so yes, first we create an origin. Okay, so it seems like origin is okay, so let me explain what I'm trying to do here. So we see that we create like an empty module, and we immediately set origin, and the origin of the module, be like where it originated from, is really the thing which cannot have a default. Actually, let's maybe take a step back, clean this up, and at first let's just remove default on the origin, because it's like the default which makes like the least sense. And yeah, and now this one can't have default, so we need to generate default by hand, and I really want that like this assist actually generates like a real default and not just to do, but no one so far fixed this. If you want to fix this particular issue, so to change this to do to like this thing with like everything initialized to default, you want to see let's actually back this up. Okay, no, this one I want to build data. So assist code is convert to manual impl. Let's just search for the string. Convert to manual impl. Yep, and that's the assist you should be fixing. Okay, so let's go back to the module data. Parent is online. Children are empty. Scope is empty and origin is maybe 0. Actually, don't like using 0 here because 0 is usually a verified ID. So let's just use this one to make sure that like everything breaks loudly if it is an issue. I wonder if there is some inverified ID. No, there is no inverified ID here, and that's great. Okay, so this should compile. And while it is checking, let's actually commit this. Okay, and the test actually passes, so that's already a small improvement. Okay, so now I want to actually, do you have an impl? Yes, we do have an impl for this module data. I actually want to do this correct. And I want to pull this origin into parameter of a function. I guess really Rust Analyzer should have a refactoring which allows you to select some kind of a value and say move this to a parameter of a function. Sadly, there isn't one yet, but you might want to write it. Okay, and now we can say that default actually uses is implemented like this. Let's print this as well. Perfect. Tests are passing. I wonder if I can just duplicate this impl and like this method and see if a compiler can actually tell me where I'm using it. Yeah, apparently I cannot duplicate neither the impl nor the method, which is like sad, because I don't want to create an error while refactoring. I just want some way for the compiler to flag the call sites as needing fixes. So let's just compile this out and go to this usage. So let's extract this into a variable, pull this up, and don't really like how it is called, so let's say something like this. That doesn't work. Okay, it doesn't work because we committed this out. We want to keep the code component, so let's just amend this. Yeah, I have a whole ton of details to make committing easier for me. Nice, it works. So let's now see. Yeah, that's the only usage which left. Not this usage actually has like several calls. I wonder, do we have module origin for a block? Yes, we have module origin for a block. I wonder who is setting this. Yeah. So I guess we want to move this assignment from here to here. Okay, so yeah, I'm like, note that I don't change the empty function in place. I add a new function so as to keep the code compiling. And here I want to say something like this. Okay. I wonder what a block log is. So block log is IST ID and module ID. And here I think we want just the IST ID, so let's just do this. Okay, I wonder if this compiles. This doesn't compile. Why? Okay, because again we wait. Yes. We can edit this out, so this now should compile. Shouldn't it? Yeah, it compiles. Let's now test this to check that we have to apply the refactor. Entity. And this actually should be easy to tell because this is like create root, but it's not super clear. Okay, I'll take this back. Okay, test suppressor. Who sets the module origin to create? yeah, I will go and invoke find usages on, like that's a horrible hack. So basically, if you invoke find usages on a curly brace or a parenthesis, we will look not for the usages, but for the places where you create this invariant. Sadly, this code would not send a find usages request for a curly brace because it only sends this for an identifier. So we need to move curly brace next to identifier and then invoke find search. And then in Rustmizer we understand that hey, you're like looking for a curly brace. And yeah, here we see that basically we want these two things. Do we need file ID anywhere else? Yeah, we do need file ID there. Okay, and I forgot where we were, so let's go back to the empty function. And its call site. And what we want to do here is we want to say, yeah, we use a create graph a bunch here, so let's extract into the variable here. Let's inline this. Extract this. This looks correct to me. I'm slightly concerned that we are, yeah, probably not a good idea to extract create data up to this level, because we're actually using, because then it needs to go before profiling call. But if we move it here, then we don't have it here, and it's like important to divide it. So let's just duplicate this. Oops. Yeah. Okay. This looks reasonable to me. Let's look if this looks reasonable to the compiler. No, it doesn't look. Yeah, because. Okay, so it seems like we need another variable here. Actually, expressions can probably be in line because we do want to like save this call via salsa, but just simple indexing is not really necessary. Okay, so now the empty function is unused. So let's rename empty to empty2. And go to module data. And I think now, okay, yeah, let's check if this compiles. It doesn't compile. Okay, yeah, because there was another usage there. Okay, this is for tests. And that we can conveniently we can reuse file ID here. Why is it definition? Why is this called definition? Okay, so I believe now we can get rid of an extra default info. And actually, let's, while we are at it, document that we don't do this kind of default inputs in raster either. It's not that this is like horribly wrong, it's like not even wrong, but I prefer to work in the code base where it is like uniformly true that if a value has a default, the default is actually sensible empty object. Okay, it should go to the, it's definitely, I guess it's called code section. Yeah, it should go to the constructors section. I wonder if I should create a new section here. Yeah, I don't think it's needs a new section, just to mention. Yeah, I don't. Okay, let's do something and then change later if we need to. I wonder what's the right name for this method? Like default, which is like it's not incorrect. Avoid done. Yes. That means it's separate paragraphs. Okay, and I guess we can merge this into existing pull requests. Now let's create a new branch. No default. And let's send a pull request. Okay, we edit some code, we remove some code, we edit more code which we removed, which is bad, but at the same time we removed something which might break internal endurance. So I think that's a good use of our time. Again, recall that original goal here was to fix a potentially quadratic visibility of operation, which we didn't get to, but we made our code base easy, which is great. Let me just quickly run a test to double check that everything actually works, and then we will wrap it up. Rust compile times are horrible. Okay, everything works, so presumably that's it. Let me stop recording that. Bye.